All right, so in example 3, we're going to find x and y in the diagram. So this diagram is starting to look a lot more complicated, but the first thing I see is that these lines are parallel, which is a great sign because when I have parallel lines that are cut by a transversal, I have a transversal P here and I have a transversal Q here, I know I can use the corresponding angles postulate, I can use the alternate exterior angles theorem, the alternate interior angles theorem, and also the same side interior angles theorem. Yeah, same side interior angles theorem. Okay, so I can use all 4 of those, okay? So I just need to figure out, well, which one do I want to use? So what I notice is that there's information here and here, but there's like 3 parallel lines. So sometimes when stuff starts to get complicated, I like to pull out my highlighters and my colored pens. So I'm just going to look at, so there's 3 parallel lines, but first I just want to look at this parallel line and this parallel line and kind of ignore all the other stuff. And I want to look at this transversal here. Okay, this transversal. Okay, so I'm kind of ignoring that line in the middle and I'm ignoring this transversal here. So basically, what I have here, the inside of these 2 yellow lines, these are interior, okay? So that means that these 2 angles, they're on alternate sides of that transversal, so they're alternate interior angles. So whenever we have these lines that are parallel, we know that these are congruent. So what we can say is we can just, this is really just an algebra, it's not a proof one. So I'm just gonna go ahead and just state that these, well, I'll say that these 2 lines are parallel, parallel first. So we'll say, you know, line L is parallel to line N. Therefore, we can say that these 2, and that's just given information, we can say that these 2 are equal. So I'm going to say 5x plus 4y is equal to 55. All right, so I have an equation there. Okay, so I have that equation, and then what do I have? I have this other information here. So notice that there's 2 variables here, so I can't just figure out what x is and I can't figure out what y is. Whenever you have 2 variables, you actually need 2 equations. So I'm going to look here at this information, and I am actually going to look at these parallel lines. So this parallel line here and this parallel line here. So those 2 are also parallel. That's where this information is. And now I have a new transversal, which is this transversal right here. Okay, so now I'm kind of ignoring all of this information on top. I'm ignoring this over here, and I'm just kind of looking at this section, right? And if you can see, you got 2 parallel lines cut by a transversal. So these 2 angles, these are corresponding angles, so we know that they're equal, right? So the second thing I'm going to say is because we have line M is parallel to line N, what I can say is that 5x plus 5y, did I say that wrong? I probably did. I'm sorry. 5x plus 5y is equal to 60 because of the corresponding angles postulate. So now I have my 2 equations right here and right here. And I'm not going to do this as a proof, okay? 2 equations, 2 variables. So we're going to kind of go back to algebra here in chapter 5 in algebra. Do you remember it's a system of equations? So we really have a system of equations here. 5x plus 4y. Do you remember that? There was like 3 different ways to solve it. The first way was to graph it. The second way was through using substitution. And then the third way was using elimination. So I think the easiest thing to do here would be to use elimination. Remember, when you have a system, you want to have, you want to eliminate one of, did I say, I meant, elimination, right? That's the way that you want to do it. Whenever you do elimination, you need to have a variable that is the same number except one's positive and one's negative, right? And basically then what happens is that variable cancels out, and then you can figure out what the other one is. So so right here I see that I have a 5x and I have another 5x. Okay, so this is very, very like convenient for it being using elimination. The only problem is they're both positive. So with elimination, I need one positive and I need one negative. So I'm actually going to call this my equation A, and this is my equation B. And so what I'm going to do is I'm just going to multiply one of these equations by -1, and if I do that, then what's going to happen is it's going to make one of these 5x's negative, which is what I need. So I'm going to multiply this entire equation by -1. Okay, that means -1 needs to be multiplied that. So my equation B, this is my B, -1 times 5x is going to be -5x. -1 times -5y is going to be -5y. And lastly, -1 times 60 is going to be -60. Okay? So this is my new B, and then I'm just going to rewrite A, my equation A, here. Okay? So I'm actually going to do the elimination with these two equations right here. All right? And really, it just becomes like one big addition problem. Okay, so you go -5 and you go down like this, like old school, like 3 plus 4 is 7. Okay, just like 3x plus 4x is 7x. That's basically what we're doing here. So we just go down. So -5x plus 5x, I'll put a plus here. That just, those cancel out. And then we have -5y plus 4y would end up being -y equals -60 times, no, I'm sorry, -60 plus 55, what is wrong with me, is -5. All right, then we just need to figure out what y is. So it's negative, we got to get rid of the negative. I'm just going to multiply both sides by -1. Negative times the negative is positive. I got y equals negative times the negative is a positive. I got y equals 5. Awesome, awesome. Now I need to figure out what x is. So I'm going to pick one of these equations, A or B. I'll just go ahead and pick A. 5x plus 4y equals 55. And I'm going to substitute 5 in for y. So that means I have 5x plus 4 times 5 equals 55. So then we end up with 5x plus 4 times 5 is 20. And now we're just solving for x. So we're going to subtract the 20 to both sides. That cancels. We're left with 5x equals, what's that? 35, and then we got to get x by itself. This is multiplication. Inverse operation would be division. Division property of equality. 5 divided by 5 is 1. 1 times x is x. 35 divided by 5 is 7. So we have x equals 7, and we already figured out that y equals 5 up there. So boom. There you have it. Okay, so that is super fun. It's almost like geometry and algebra had a baby. And there you go. That's those problems. So let's look at the next one. Here, I know this is a check it out, but I think we should just go ahead and do it together because, you know, geometry and algebra, they're having a baby, and I just think that we should just practice this again. If you want to pause and try this on your own, you can, but I'm just going to go ahead and start with it. So let's look at all this stuff. What do I see? What do I see? I see there's a lot of stuff going on. There's some different algebraic expressions, some numbers here, but what the most important thing I see is I see that I have some parallel lines. Okay, yes. And 3 parallel lines. And then I have 2 different transversals going on here. So let's look at these first. Look at these numbers here. And I'm just going to look at these parallel. So it's a complicated picture, so I'm going to take out my highlighter. And really, I just want to look at these 2 parallel lines and this particular transversal right here. So the most you can do, please ignore everything else. Like if it would help you, sometimes if stuff gets confusing, I would just make another picture and draw the transversal here and then put, you know, so this would be my yellow line, and then this would be my pink line right here, right? And then I know that they're parallel. So being that they're parallel, that means I can use the corresponding angles postulate, alternate exterior angles theorem, alternate interior angles theorem, or the same side interior angles theorem. And then I just kind of put these values in. So it's really the same picture. It's just with, this is really what, okay, that's bothering me. I need to have a better pink line. That space there. Okay. Okay, wait. I can do, Joy, you can do this. Okay, there you go. There's my highlighting skills for you. So if sometimes I like to take a complicated picture and just make it simple, because I know I have these, and so I'm dealing with one of those 4 theorems. And if you look, they're on alternate sides of that transversal. So it's really going to be alternate interior angles, which would be inside, or alternate exterior angles. And that's what we're dealing with. We're dealing with the alternate exterior angles theorem. So we know that these two are the same. So, you know, sometimes if that makes it easier just to make a simpler picture than all of that, sometimes I do that, because it's hard to look at all of this. It looks like a big hot mess. I mean, I understand. But I'm just going to go straight to the algebra, because this is really just a geometric algebra problem. It's not a proof. So we're just going to say that this is equal to this. So I'm going to go 25x plus 5y equals 125, right? The only reason why we can say that is because these lines are parallel and we're using the alternate exterior angles theorem. Okay, cool. So that is our first equation. And then I'm going to look at this other information down here. Okay, so we have 2 parallel lines here. I'm going to use green for this one. So we have this parallel line, and we also have this parallel line, except now we're looking at this other transversal, which is right here. Oh gosh, let's see if I can do this one right. Okay, so now we're looking at that transversal. Okay, so what do we have? You know, if you wanted to draw a different picture, you could. You know, otherwise, sometimes I just like to use my hands and just, you know, there you have it, right? Just ignore everything else and just look at this. So the transversals right here, we're on the same side, right? And this is on the right side of this line, and this is on the right side. So we know that we're dealing with the corresponding angles postulate. Since these lines are parallel, that means that the corresponding angles postulate says that these are equal to each other. So boom, that is our second equation. And notice that, what do we have? What do we have? We have 2 variables, right? Oh, find the measures of the acute angles in this diagram. Huh, that's different. Okay, boom, 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 boom. What a weird thing. I really just think they want us to figure out what X and Y are, but anyways, we'll just go with this. Okay, so okay. So here, right, we have our two variables and 2 equations. So we need to figure out what X and Y are. So this is where we go back to systems of equations, right? There's graphing, there's substitution, or there's elimination. And I think it would be clear that we'd use elimination because we have 25 here and 25 here. The only thing is that one needs to be negative. So I'm just going to multiply this equation number 2 by a -1. Okay, so I'm going to multiply this whole equation by -1. And then that's going to give me the same number, but one's positive and one's negative, which means that will cancel out. And then I'll just be left with one variable, which is what I need to figure it out. So negative times 25 would be negative 25x. A negative times 4 would be negative 4y equals negative times 120 would be negative 120. Okay, now I'm going to rewrite that equation number 1 right underneath it. And then it's just like one big addition problem. So I'm looking at these two equations and just, you know, adding them together, which I'm, you know, it's just, okay. Adding them together vertically. So negative 25 plus 25, those cancel out, that's just 0. Negative 4y plus 5y is just y equals negative 120 plus 125. This is a negative, this is a positive, so you're finding the difference. The difference is 5, and this is the bigger number. The bigger number is positive, so our answer is positive. Y equals 5. All right, so then we just need to figure out what x is. I'm just going to choose this first equation. 25x plus 5y equals 125, and substitute 5 in for y. 5 times 5 equals 125. Plus 5 times 5 is 25. Then we just solve for x, so we're going to use the subtraction property of equality. Those cancels, we're left with 25 equals 125 minus 25 is 100. Oh, this is 25x, my bad. We're trying to figure out what x is. We divide both sides by 25, and we end up with x equals 4. So there we have it. Those are our two answers. X equals 4 and y equals 5. I just really think that this is, I wrote this down wrong, find the measures of the acute angles. If you needed to find the measures of the acute angles, all you would do is stick x and y in there and then just go 180 minus, because all of these are not acute. So like 180 minus 125 is that. 180 minus 120, so that's going to be 60, right? So this would be 60 degrees. What would this be? 180 minus 125, so that's going to be, what would that be? Would it be 45? No, 45, 55. Yeah, 55. So this is going to be 55 degrees. Yeah, and then that might be it, because these are these are parallel, so this is 60, and these are parallel, so this is 55, and these are, you know, I mean, you can just fill them all in. This is the corresponding angles postulate, 55 degrees here, and then vertical angles, 55 degrees, vertical angles, 55 degrees, vertical angles, 55 degrees. These are parallel, so corresponding angles postulate would give you 60 degrees there, and then vertical angles. So those are really all of the acute angles there. So to answer the question, the acute angles equal 55 degrees and 60 degrees. Those are all the acute ones, because all of the other ones are obtuse. So, you know, all of these other ones would be, you know, 125. That's really 125 too. And these would all be 120 over there. So yeah, acute angles, 55 and 60. All right. Perfect. Okay, have fun, you know, with the geometry and the algebra together. It should be fun. All right, see you later. See you in a bit with lesson 3.